similar, and we're going to probably use the same kind of ideas, but it's different. One way it could converge to an interval. What does that interval mean? What does the word interval mean?
Two set of numbers.
Yeah, the two endpoints, okay? So it may converge to from this number to this number. If you imagine this is the center, I think I marked it as x equals c, it may converge from this number to this number, okay? So there's wide variety of numbers. I don't want to use the word range because then don't get confused with the range of a function. Okay, that's the interval. Now, what about the endpoints? Will it converge to the endpoints? We don't know that. We actually have to test for that. So the endpoints, you may want to write this down, may or may not be included. Okay? If it converges to the interval, then we have to find the radius. The radius is, what's the radius? The distance from the center, right? So the radius would be distance from the center of the series to the endpoint. Okay. So now, if it's not going to converge to an interval, then the other option could be it converges to all real numbers. So, which would mean negative infinity to positive infinity.
What is that little a right there for?
That is for the radius, actually. Okay. My writing literally disappeared from my iPad. I'm like so confused on what happened here. Okay. It could converge to an interval, it could converge to all real numbers. And the last option is it only converges to the center. Okay, so to find the interval, so these two are actually easy. We don't have to really worry about if it converges to the all real numbers. Take your AirPods off. When it converges to all real numbers or when it only converges to the center, we don't have to do a lot of work. But when it does converge to an interval, we do have to do a lot of work, okay? How do we decide whether it converges to an interval, all real numbers, or center? Good old ratio test. But the way we use the ratio test for convergence is going to be a little different. Pay attention, children, I'm giving you a lot of stuff here. It involves only limits, literally limits. Okay. Here are the three ways that you're going to set it up. Okay, if you have, I think most of it is given to you right there, right? If you have a power series, summation n equals infinity a sub n, find the limit. Remember the ratio test? We have the a sub n plus 1 over a sub n, and you do the absolute value of it.
180.
Okay. When the absolute value or the limit is actually going to be less than 1, when the limit is less than 1, then the series will converge on an interval. Series converges on an interval. Now, when the limit is equal to 0, series converges for all x values. When it's equal to 0, all x values. When it's equal to infinity, then it converges to the center. The center will be different depending on what RC is. Okay? Okay, if you need more space for the problems, you probably want to write it on a different sheet of paper. I squeezed everything in because I did most of the simplifying in my head. But there is a lot more you have to do, at least for problem 1, 2, and 3. Okay, when you're doing your limits, pay attention for a second here. When you're doing your limits, when it comes to this, when it's less than 1, we have to do extra work to figure out if the endpoints are going to be included or not. Okay? Because that converges on an interval, and the interval, depending on what the thing is, the interval may or may not include the endpoint, so we always have to check. These two don't matter. If you get your limit to be 0 and infinity, you don't have to check for endpoints. Are you listening to me? Are you understanding what I'm saying? Okay, let's do some problems.
Can you do it back? Please?
Okay, we are finding, the question will probably ask, find the radius and interval of convergence. This will be part of your finals. This, especially this outcome, is part of your finals. Okay, this is a power series, not an infinite series, because I see the x there, so it kind of tells me that I have to do some expansion and whatever, and I have to look at the center. What's the center here?
Negative.
Positive 5.
Oh, left.
Just write it down so that you're practicing also finding the center. Even though it's required, even though if you need it or not later in the problem, doesn't matter. Okay. Now, what we're gonna do is we're gonna do the ratio test to figure out what the limits are. So, which means I have to find a sub n plus 1. Okay, so every n is going to be replaced with n plus 1. We're going to do the ratio test. So limit n approaches infinity, absolute value, don't leave that out, is going to be n plus 1 times x minus 5 n plus 1. I will do the simplifying just for this one, like show it to you, but the rest I won't show the simplifying. Times 3 to the n over n times x minus 5 and then absolute value. Okay. So now let's do some canceling, simplifying, all of those stuff. I'm gonna separate this. Then separate this. Okay, we can cancel this out. This goes away, this goes away. Are we good? Okay, I'm gonna group these terms so that I have the x together and the n together, so it's easy for me to kind of see. Are we ready? Because I have to like point out a few things for you here. What's the limit for this part? 1. Okay? I'm not talking about the entire limit, just for this part. If you know this is going to be 1, okay, and it's not 0 or infinity, right? It's not 0, it's not infinity, then the entire thing has to be less than 1. We're just going to assume that if this is going to be 1, then this thing has to be less than 1. Okay, this is how you determine it. When you look at the n limits, you're just going to make the decision based on that. If this is equal to 0 or infinity, then the entire thing is going to be 0 or infinity. If this is not 0 or infinity, no matter what that is, it's going to be 1, then the entire thing will be less than 1. Okay? So now, if the limit is less than 1, where does it converge to? It converges to an interval. Okay, so then we're going to have to set up and find that interval. That's where the absolute value comes into play. Remember, that's what we did for the ratio test. And I know when we did the ratio test, there was like 1 or 2 problems where I said, find the value of x that's going to converge absolutely whatever, right? This is what I told you. I just want you to practice that so we can, this is why. I want you to practice that so we are setting up for this. Okay. We set it up like this. And then we split it into -1 and +1. Okay. Since we are calculus students, I'm going to actually do it in one set. Like that. Instead of separating into parts, I'm putting it into one set. Okay, it's the same thing. Okay, now you're multiplying by 3 on both sides. So that'll be -3 less than this. And then you're adding 5 on both. -3 plus 5 would be
2.
+2. 3 plus 5 is 8. You may need more room because we still have to do more things. So if you need more room, like make sure you have a separate sheet of paper and...
Bless.
Okay, but we don't know if the endpoints are actually included or not. Okay, this is where you have to be careful and always remember to check for endpoints. This is not the interval of convergence yet, unless we check for the endpoints. Okay, how do we check for the endpoints? This is where your series test is going to come into play. Okay, I'm trying. Okay, remember the endpoints 2 and 8, okay? So now I'm going to check for the endpoints. I'm going to check for 2. How do I check for it? I'm going to take the 2, plug it in. When I plug in 2 for x, what is 2 minus 5? -3 to the n. What is this series? Does it converge or diverge?
Diverges.
How do you know?
Because it's a geometric and the
It's okay. Geometric and alternating. When it alternates, it's going to diverge. You can, I think I kind of simplified this actually. Here, if you don't see it right away, you simplify it as well. See how the 3 and, like you can separate them a little bit here. I can separate it as this, and that's totally fine to do. Okay, so this and this cancels out. This is an alternating series. Literally, it's -1, +2, -3, +4, -5, +6, and so on. So that diverges.
So does that mean that that endpoint?
That this 2 is not included in our interval. Okay, it has to converge for it to be included. Okay, now we still have to check for the other one. Sometimes both will diverge, sometimes one will diverge, one will not, you know. So we have to adjust that accordingly. What's the other one? 8?
Mm-hmm.
So now you plug in the 8 in place of x. And what do we have?
3.
3n?
Uh-huh.
Okay. Whoa, my sweater is really... Okay, what happens to this series then? It diverges, it's getting larger and larger because it's a natural number, right? It's series of natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, this also diverges. Since our endpoints, both of the endpoints diverges, we can just say the interval is what we have. So I would like you to actually circle or actually summarize your answer and write interval of convergence is this, right? Because you did all the test and check and everything, and we finally decided that this is the interval of convergence. So what about the radius then? What's the radius of convergence? From the center. What's the center? 5, and the endpoint is 2 or 8, either way. Center is 5, 2, 8. What's the radius?
3.
3. It's a distance from the center to the endpoint. If I do it on the number line, this is the center 5. The endpoints are at 2 and 8. What's the distance? 3. The distance has to be the same from the center. So the radius is 3. Okay? Okay, let's take a break before we move on.
I don't know, do you want to?
Oh, wait.